Hi, this is a video on voting power. So once you have an apportionment set, then you can calculate the voting power of each state, or in this case, the voting power of each campus. The math instructors all get together in the Math SAC, or Subject Area Committee, and it's a democratic process. So we vote on curriculum, textbooks, things like that. And we also have a lot of part-time faculty who vote, so this is kind of oversimplified, but I want to do an example where we calculate the voting power. Okay, now this is the actual apportionment right now of the math instructors. So let's compare. We have Sylvania has 18, Cascade has 8, Rock Creek has 13, and Southeast has 6. So let's go back and look at our methods and see how these compare. So with Hamilton's method, it was 1710, 13.5. So one from Sylvania and one from Southeast would have gone to Cascade. Jefferson's method was 18.9, 13.5. So one from Southeast would go to Cascade. And the other two I think were the same as Hamilton's. Different methods, but they came out with the same outcome. 1710, 13.5, and Hill-Huntington was also the same. So it's close, it's not exact. One of our math instructors is in a Gateway to College program, so it's a little bit different situation, but things like that, there's all kinds of unique situations to apportionment. So here's what we have, and we want to calculate the voting power. Okay, so we've got the student FTE and the number of math instructors. So we want to know the number of students per full-time math instructor. So this keyword per means divide, and then we need to look at which one comes first so that we know which way to divide it. It says students per instructor, so we're going to take the students divided by the instructors. So let me write it out first. So this will be 8871 divided by 18. Calculator. And that is 492.83. Remember, because it's just roughly proportional, because we have a whole number of people, the voting power is not going to be exactly the same. It would if it was exactly proportional, but that's going to be pretty rare. Okay, Cascade, 4841 divided by 8. I'll write these all out. Rock Creek, 6797 divided by 13. And Southeast, 2722 divided by 6. Okay, so 4841 divided by 8, 605.13. Wow, that's a big difference, isn't it? Let's do Rock Creek. 522.85. Southeast, 2722 divided by 6, 453.67, 2/3. Okay, so what this is saying is at Sylvania, there are this many students per one full-time math instructor. At Cascade, there's this many students. So you can see the smaller number, the better. Southeast, because we have the 6, is actually better represented. And Cascade is the worst represented in terms of full-time math instructors. So this gives us an idea of voting power. And it can be calculated either way. We could have done math instructors per student. That would be a very small decimal. So it's just important to read which way the problem reads, which way you're supposed to divide it. And then we will look at voting power of the states in our class activity. So thanks for watching, and I will see you in the next video or in class.